In this video, we'll introduce section 2.1, which is a preview of calculus. So let's start by looking at a few different lines. So here on the left, we see f of x equals negative 2x minus 3. And we can see that it has a negative slope, right? The line is sloping downward when you go from left to right. In the middle, we have g of x equals x over 2 plus 1. And that has a small upward slope. Eric, what is the slope of that one?
1/2.
1/2. So you can see that coefficient on the x term. And then what about this last one? This last one's just a flat line. So what's the slope of that?
So I think the slope is rise over run. So I'd say slope is 0 because it's no rise and all run.
Yeah, that's a good point. And here too, we can see that there's no x term, right? And so we can even think about the coefficient on x as being 0. So you've probably encountered lines quite a lot. It's a big focus in high school or pre-calculus. And it's really easy to find the rate of change, right? Because we can look at the coefficient on that x term and we can see how the line is changing as you change an x value, how the y value changes. So for example, from the negative 2 here, if we go over 1, then we end up going down 2. Okay, and that's why the rate of change, the slope is negative 2. For the middle graph, if we go over 1, we end up going up by only 1/2. Another way to think about it would be that if you go over by 2, then you go up by 1. Okay, so the rate of change is much slower, but it's a positive increase. Every time you move to the right 1, you move up 1/2. And then in the rightmost graph, we can see that every time you move to the right 1, well, you don't go up at all. You go up 0. Okay, so Eric, what makes this curve a lot harder when we're thinking about rate of change?
Well, the fact that it actually has curvature to it. It's a parabola.
Right, it's no longer a line. So it doesn't have a constant rate of change anymore, right? Sometimes if we go to the right 1, we go down a whole lot. Sometimes if we go to the right 1, we go up. So we can still think about rate of change, but it's not just a number anymore. The rate of change is changing all the time. One way to think about this is with tangent lines. So for example, at this point, let me change colors. At this point, we can think about the rate of change as being the slope of this line, where it just touches the curve at that point there. And that will be one of the big things in calculus, is trying to calculate the slope of those tangent lines or the rate of change at that particular point. That turns out to be a little bit tricky, but what we can do to start is to calculate the slope of a secant line. So over here, if we're interested in the slope of the tangent line at this point, which would actually look kind of like this, what we can do instead is we can take a point sort of nearby and we can look at that secant line because we know how to calculate the slope of a line through 2 points, right? By using rise over run, right? So the difference in the x value or the y values, f of x minus f of a, and the difference in the x values. Now for this particular example, since this point is so far away, the slope of this line will be very, very different than the slope of this line. But that's okay, we're going to get to that because we can move this point closer and closer. And that's something that we'll be practicing.